Hello guys, this video is about a client server model where one host will be a client, the other host will be a server, and we are communicating these two hosts by using a socket. Make sure to run this in a small private network, and if you are using a virtual box, then please go to settings, then network, and change the option from NAT to bridge so that two PCs in the same network will be able to communicate with each other. We have different types of codes here. These vary. We use different types of sockets. There are two types of sockets, that is stream socket and datagram socket. And for stream socket we use a TCP connection. Here is the flowchart for the TCP connection. Please make sure that you run always the server first and then the client, because when the client tries to connect to the server must be active. So here the server program must be running. Server creates a socket, binds it, and actively listens for a connection request. When the client creates its socket object, it specifies the address of the server process, namely the IP address of the server and the port number of the process. TCP in the client initiates a three-way handshake to connect to the server. Now the server receives the connection request, accepts it, and blocks it until the connection is successful. Then the client will write some data into the socket. That data will be received by the server. It processes the request, write backs into the socket, and that is received by the client. Then the connection ends. And here is the flowchart for the UDP. The only difference is from the TCP to the UDP is that in a UDP there will be no three-way handshake which we require. The flowchart is way too simple. That is, the server creates a socket and it will wait for it binds it and waits for some request, and the client will create the socket, send the request, and then the server will receive request, process it, and send it back to the client, and the socket is closed.
So this is where we will be running through the code. We will have two codes. One is for server.c and one is for the client, which is client.c. So in this we are trying to establish a TCP connection between the client and the server. So when we are running the server, we need to mention the port number of the server, and so we will run the server executable as /server followed by the port number. So here we can see that in this code we are accepting the command line argument. So here we save the port number, and then we have created the new socket which is called as sockfd, and since this is an internet domain socket that we are creating, our first argument over here is EE542 So this means that the address family is in the internet domain, and in the internet domain, since our streaming is a socket streaming rather than a datagram streaming, we are using this symbolic constant of sock_stream, and this 0 over here mentions the protocol. So the server automatically detects what protocol it has to use, and whether it's based on socket streaming or whether it's based on datagram streaming. And in case the socket is not created, that happens when we return a -1 in this particular socket system call, and then we display an error that there is an error in displaying the socket, in opening the socket. So now we are creating the server address because we need to bind the server address into the socket. So first we will initialize the server address and make it 0. The server address is basically a struct of sock address _in, which is defined in the library of socket.h, and now we will be initializing the variables inside this particular struct. So the variables we are initializing is the port number, then the server, the family, which is AF_INET, and then we are selecting that IN address_any. So this means that any IP address of a machine can be picked up by the server. So we are not restricting the server address to have a particular IP address over here. and the port number is typically there in the format of the host address type, and we are converting it from the host address to the network byte order over here. And then since we have created the socket and we have created the server address, now we need to bind the server address into the socket. So that is done using the bind system call, wherein we are passing the socket and we are passing the server address as well as its size, and if there is an error we again display that. So now since the socket has been created and the address has been bind to it, the server will actively listen for connections. So this 5 over here is a number which indicates the queue size, and it's typically 5. And now since we are actively listening for connections, the accept system call is a blocking system call, wherein it will block until it receives a connection request from the client. So once it receives a connection request from the client, we save the new socket in new socket fd, and we are creating a new entry in our file descriptor table. So basically here we are creating a child process of our initial process, and then we are doing the reading and the writing of the buffer. So anything that the client has written into the buffer, we are reading it into new socket, and then the server will write it back that it has got the message. So this is the acknowledgement that the server is writing into the socket. And after this we just close the new socket that we had created as well as the initial socket. Now we'll go over the client code. So in the client code, what we would be doing is we will be creating a socket, and then we will be sending the connection request to the server. So here we have created the socket, and the process is the same as we did for the server. And yes, so here after we have then initialize the server address, we copy the server address details that we get from get hostname. The details are getting saved in server, and then we are using these particular details to connect. This is the connect system call over here, and then we write our message into the socket which is received by the server. And in case there is an acknowledgement or anything that has been written from the server, so this is where it is read and it is printed on, and then we finally close the socket.
The sample server code though has the limitation that it can accept only one connection and then it dies. But what if we want the server to accept multiple connections? Then we should use the concept of forking, where we create new process for each new connection, and this can be done by using a do stuff function. So the main changes which we have to do in the program are very simple, that the accept statement must be put in a infinite loop. Then the socket will be created every time a new request is being received, and then the connection is established, and call fork to create a new process, and the child process will close socket fd and call do stuff, passing the new socket file descriptor as an argument. When the two processes have completed their conversation as indicated by the do stuff, this process simply exits. The parent process closes the new socket fd because all of this code is an infinite loop. Then one more code will be when we want to run the sockets in the Unix domain. The only change in the program will be that we have to use AF_Unix. Address family will be in Unix, and even in the server function, when we create a new socket, then we have to use AF_Unix. Now let us look into the code where the client and server communicate with each other using the datagram socket. Servers using datagram socket do not use the listen and system accept calls.
And the difference from using the datagram socket and the stream socket is that when we create a socket here, we'll specify it as sock underscore datagram socket, and we don't have the connect and the listen, so here we use the send to and receive from functions, and the receive from function has the following parameters, where sock is the file descriptor and we have a buffer to where we'll write and receive the data from, and this is the size of the buffer, and this is the address of server. And in the send to also we can use here the message is directly written, so it is got your message and the size of the message is 11, so and so. And in the client code also the difference will be that the socket which is created is the datagram socket, and the send to and the receive from function which is sock in the server code.
Now we'll first run the server code. So to connect to the server, we need the host name of the server, which can be obtained by the host name, which is Ankita, and then we'll run the /server and we'll give the port number. Please make sure to give the port number more than 1023 because the port numbers from 0 to 1023 are reserved. Now the server is active. Now in another PC we'll run the client code. Now here we have two arguments, which is the host name of the server and then the port number. Now it asks for a message. I'll just type hello, and then this message will be received in the server. Yeah, this is the message in the server. Now we'll run the enhanced server, where the server will accept multiple connections. The port name is as explained before, and it says the port number is already in use, so let us change the port number. And now the server is active. Now let me run the client code. I'll say hello, then I'll run it once more. So second message, and then third message. Yeah. Now the server will have received all these messages using a single connection, which we can see. Now we'll run the UDP server. The command is the same. Now let us run the client. I'll say UDP success, and that is received by the server and the connection is successful.